Hello, everyone. Welcome to another Fabric conversation at Microsoft Fabric Cafe. My name is Mirad Abdullahi, the community lead and the organizer of this great community, and also the host. So let's see who we have today, and just feel free to say hi in the comments and let's introduce yourself. I'm gonna share my screen as usual. So let's kick it off. Cool. Today, July 5th of 2025, 7 a.m. Pacific time on my end in sunny Vancouver today. The Fabric Coffee Session 39 at Microsoft Fabric Cafe. So this number is increasing, and I'm super happy to be more consistent and actually stay consistent in these sessions. And I try to stick to my commitment. And thank you very much for your interest in these kind of sessions, which is really a good, power for us to continue. So we are part of the Microsoft Learn community. For those who doesn't know, and if you know that, it's going to be some repeated things as usual. But yeah, we are part of the Microsoft Learn community. Basically, we are a learning group in Microsoft Learn. Microsoft Learn has no community, is a tech community. Basically, there you can just stay updated with the latest news, and you can ask questions, explore the certifications, and with the guidance from experts. So there are some learning groups or learning rooms that you can just join them based on your interest. It is going to be a role or even a specific application in Microsoft and Azure landscape, and you can connect with your experts, ask the questions, and also connect to your peers and get and provide support to each other. So there are lots of rooms and groups there, especially for Microsoft Fabric Cafe. With over 4,000 members globally. It is a global community. So, and we are focusing on Microsoft Fabric and Microsoft actually Power BI. And we provide learning and support to Fabric users in all levels. It is a forum for everyone to share, learn, and grow skills together. We've got our social here, the social platforms. On YouTube channel, you can watch, actually rewatch all of the past sessions. You can also watch the live sessions and stay tuned for the upcoming sessions. So feel free to subscribe on that and check all of those past sessions in the past year. We're already actually, yeah, we're almost in the celebration of our 1 year in Microsoft Fabric Cafe. And on our LinkedIn page, we do all of the announcements, all of the updates from community, from Microsoft Fabric and Microsoft Learn. And also the new created group in Microsoft Community Group, which we actually we are in the transitioning from our Teams, Microsoft Teams channels and groups to this, web-based group. You can just use the tinyurl.com/msfabriccafe. And also on our meetup group, we do all of those, announcements that you can RSVP and again, stay tuned. And the good thing about the meetup is that you can just rate the session that you have joined, and it is going to really help us to understand what we can do better. And also it is going to show others how did you like the session and the whole community. We recently added Reddit to our social media accounts actually, then there you can just join us there if you're a user of Reddit called Microsoft Fabric Cafe again. There's a code of conduct in our live sessions. Whoever is going to attend our live sessions or even in-person sessions when we have it, there's a code of conduct. Thank you very much for adhering to those in advance. It is on the screen. Be respectful, collaborate, embrace diversity, stay professional, act with integrity, use responsibly, and report issues if you see any. Our previous session with Marcus was about becoming a guardian of the star schema with Microsoft Fabric. It was a great session. If you missed that or if you want to rewatch it, feel free to go to the YouTube channel and just to watch it alongside all of those past sessions that we had before. But for today we have Bas Land from Netherlands, and he's going to walk us through how we can custom Python modules in Microsoft Fabric to just maybe reuse them, and it is going to save lots of hours for us. Cool. I'm super excited to learn about him, and I'm Mered Abdullahi, also the host of the session. If you missed this first section, I'm gonna invite Bas to the stage. So let's see what he has for us today. Hey, Bas.
Hey, good morning
Uh,
for you, I think. Right,
for me, it is good. Good
it's
morning. It is
4 p.m. here in the Netherlands, so it's an afternoon
it's
already here.
cool. Good afternoon. Maybe almost evening for you. But
Almost, almost.
yeah, it is 7 a.m. on my end. With the love for the community. Cool. We have a hi from Nigeria, Delta State.
Oh,
Welcome to the room. And yeah, plus, I'm super excited to learn about how we can save hours, which is very important actually in today's really world. With lots of things that are happening in the organizations. We're actually hearing about the layoff stuffs, or even the resources of the actually tech resources are expensive, right? And the less we keep the hours from tech resources, the more you know uh, maybe productivity and the more outcome will be there. And I know you're running your own business, so it is very important how we're gonna save the hours. So can you just give us a little bit, an overview of what's happening, or you want to share your screen? Oh, well, I see you've already shared that, but before I hand the session over to you, can you just just without spoiling, can you just let us know what's happening?
yeah, definitely. Thanks so much. Yeah, so my name is Bas Land, and I think I became a BI consultant for a small consulting firm here in the Netherlands about 12 or 13 years ago. And I was very lucky that I had a boss back then, the director of the company. He was very stringent on saving time, right? He said every time you do something twice, you automate it instead of doing it a third time, right? That was the rule. And I was a very junior consultant, so I thought, okay, this is apparently what's happening. So that was ingrained in me. And now 12 or 13 years later, I'm very happy that that happened because time of busy professionals is really scarce, right? It's there's a lot of work to do. It's very hard to find good data engineers or good BI analysts. So let's try to not repeat ourselves and do things multiple times manually. And that is what this session is all about. It's about saving time by creating Python modules in Microsoft Fabric in order to give you back hours every day. And basically, it is about creating repetitive code patterns. I will go through a little bit of theory. I will do a live demo on a very I think, a very dumbed down version of what we're actually doing, but it is to showcase the patterns. And what I hope that after this session, the people that are looking are inspired to rethink their own data engineering work that they do in Microsoft Fabric, to see how can we abstract some of the code out of the Fabric notebooks, put it into a Python module or library in order to save time and increase the quality of our work. So that's
Awesome.
a little bit of what we're trying to do today.
Awesome. Awesome. I'm myself, in my career and where I work, and even for my daily stuffs that I have for the personal development. Uh, I'm a big advocate of templatizing
Hmm.
and automation and reusability of whatever that I'm creating. Even if it is going for one-time thing, but it may be a reusable thing for our next client or for our maybe in a year even. But I can always go back and say, hey, I have templatized that. I developed that in a way that it can be templatized and it can be
Hmm.
reused, which is very important. If we can parameterize something or templatize it, it is going to be a real good asset for the organization and even for yourself. But yeah, I'm super
Exactly.
excited to learn about that. I'm gonna share your screen and hand over the session to you guys. In the meantime, you can, of course, ask your questions in the chat. It is going to be answered by Boss right away, or in the pause. I also keep an eye on whatever that is coming there. So, Boss, the stage is yours, and I'm super excited to learn from you. Catch you later.
All right, then let's go. So the session is titled "Don't Repeat Yourself," and it's a bit of a funny thing. At least in our office, I present quite a lot. I do a lot of public speaking since a year or so, and I think I've given this session in various variances of this session. I think 6 or 7 times right now. So my colleagues are really making fun of me that I'm presenting a session, don't repeat yourself, and I'm repeating myself over and over by presenting the session. So that's maybe a bit of a funny thing. Anyway, I hope that I will be showing you guys some nice little tips and tricks today that will help you guys to never repeat yourself in your data engineering work again by inventing the wheel once and then keep reusing the things that you've already created. So we're going to be creating custom Python modules in Microsoft Fabric. That's what we're trying to do today. And then I saw this amazing thing on Instagram, I think, where you had this PowerPoint fly in, and I tried to do that. So that's this slide. All right. So what are we going to look at today? We're briefly touching the core concepts of a Microsoft Fabric Compute. I'm not quite sure what your guys' level of experience with Fabric is actually. So we're going to do some high-level conceptual overview of Fabric Compute in order to set the stage. Then I'm going to introduce the problem of repetitive coding. We're obviously going to present a solution on reusable Python modules as well. And then we're going to implement that using a live demo, after which we will have time for some Q&A, and there will also be time for Q&A during the session. So if anything's not clear, if the sound falls away, if I'm presenting something, I'm going too fast, whatever, just let me know in the comments. All right. I see one question coming in there. ELT workflows. ELT is an acronym stands for extract, load, and transform, which is which is the process basically in which we load data into a data lake and then process it into a more analytical shape. So it's the loading process for your data lake basically. Right. So let's start with the core concepts on Fabric Compute. All right. These are screens that I very conveniently stole from Microsoft, right? So these are not mine. But I think they are quite good overviews of what we're actually looking at in Fabric. But as always with Microsoft, they are changing names of their products really, really fast. And it's almost impossible for me to keep up with my slides. So the dark blue image that you see on the left side of the screen here, you will see Synapse Data Engineering and Synapse Data Science and so on. The name Synapse has been dropped from these product descriptions, all right? So it's now just called Data Factory and Data Engineering, Data Science, and so on. So please see through that. But overall, this is basically the product sphere of what Fabric actually is. Well, Microsoft Fabric is not a singular product. Microsoft Fabric is a suite of technologies and tools that we have, right? So at the bottom layer, the foundation of Fabric is called OneLake, which is basically your data lake storage for your organization. There is one lake, that's why it's called OneLake. And this one lake is the singular data lake, basically where all of your business data will be stored inside of Microsoft Fabric, that we can then segment into workspaces, into databases, into lakehouses, and so on. Then on top of that data in your sitting in your one lake, you have to do compute in order to actually run workloads. So we see the workloads on top. We see Data Factory. We might know that from Azure Data Factory. We see Power BI. Obviously, should be after 10 years now, should be known to most of us. We see data warehousing. We see data science. We see data engineering, and so on. These are all called workloads that we can run inside Microsoft Fabric, and that can do several things for us. Maybe with some overlap between the workloads, and they all interact with your data in one lake. So that's actually quite nice. So with Data Factory, we can start these ELT processes that we were talking about, and we can ingest data and run pipelines and do some light transformations. With data engineering, we can run notebooks with PySpark in order to calculate things in our data. And with data science, we can train machine learning models and then run experiments and so on. And they all interact with your one lake through a serverless compute layer. That's the layer that we see in the middle, where Microsoft has created or enabled a few different compute engines, basically, in order to run compute power, do transformations on data against the data in your one lake data lake. All right. So there's actually 4 compute engines inside Microsoft Fabric. It's a Spark engine. It's the TSQL engine that we might know of from SQL Server and Azure SQL. We have the KQL engine for streaming data, and we have analysis services that we know from SQL Server analysis services, Azure analysis services, and obviously Power BI semantic models. Today, we're going to look at the Spark compute layer from a data engineering perspective, all right? So using data engineering, we're going to create Spark notebooks that then interact with Python or Spark SQL with the data in our OneLake. All right, so on the right side of the screen, we will see a very high level architecture overview of what is called a medallion architecture within a Delta Lake environment, such as Microsoft Fabric, where we basically have data sources on the left side, data consumers on the right side. It's called Analyze, where we can actually analyze data that is in our data lake using Power BI or SQL Analytics endpoints. And then in the center is where our actual data lake with all of the storage and the compute and the logic is, right? So we see a bronze, silver, and gold lake house, which is the medallion architecture, through which data is flowing. So data sources either push their data into the bronze layer, or we pull data into the bronze layer using pipelines or notebooks. And then we start refining the data into silver, and then we start even more refining the data into the gold layer. Now, this is not a session on how to set up a medallion architecture. I did write a blog post on that, but let's assume that today it's not a session about the medallion architecture. But we can think of the medallion as being each stage as being more refined, more consumable, ready data, right? But what do we need to do in order to have more consumer ready data? We need to transform the data. We need to write code or queries or notebooks or data flows that can actually pick up data from a lower stage, such as bronze or silver, and start writing data into a transformed stage in silver or gold, right? And when we start writing code, we will see that we start writing repetitive code patterns, and that is the issue that we're going to look at today. So that is to set the stage a little bit on Fabric Compute and a little bit on what we're actually trying to do today. I'm going to close my window here for a sec. because my neighbors are remodeling their house and making a lot of noise. Um, so, okay, so introducing Python inside of Fabric. So as you by now you know that we have a Spark engine as one of the compute engines within Fabric, and within Spark we can run Python, we can run SQL, we can run I think R and Scala and different programming languages. So today we're going to look at Python. Python and Spark work together quite nicely, and there are a few benefits of using Python. And this is coming from a TSQL guy, all right? So I started my career 13 years ago. I was a BI consultant. I did most of my work in T-SQL stored procedures. And now I'm telling you that there's lots of benefits to using Python, all right? So I'm not a Python expert. I think 2 years ago, I fell in love with Python because there's extensive libraries for very common tasks in data engineering that we can simply grab, and then we can start using functions that other people created. There's loads of community support. It is by far the most popular programming language today, I think. And there's loads of flexibility in data engineering tasks. I remember that in TSQL, I had to parse JSON data that was coming in through, I don't know, whatever system or process it was. That was quite a pain. And with Python, there are things that are making your life so much easier doing that. Now, is there a role for SQL? Yes, there is still a role for SQL. I still write quite a lot of my code in Spark SQL in within PySpark notebooks. So when I'm doing regular data transformations on set-based operations, grab a set of data, add columns, change things, calculate stuff. I might still do that using SQL, but Python is giving us a lot of flexibility and a lot of power as well. And the good thing about Python is that we can package it and then start reusing it, and that will be the scope of today's session, right? So for the people that have never seen Python before, I have a few examples. And as I mentioned, I'm not a Python expert, so this is about the level of knowledge that I have about Python, maybe a little bit more, but bear with me. This is a 6-line code snippet within Python that is printing a message saying, "Hello world, the total is 3." And here actually you see that we do quite a few interesting things. We assign integer values to two variables called variable 1, variable 2 on the first 2 lines. We create a variable called total where we sum the two variables that we previously defined. And we then create a fourth variable called message. And that message is a string that is actually an F string in which we can put fixed text that I put within quotation marks, and within the accolades I can put another variable. That might not even be a string, all right? So as you can see here, it is quite easy to do manipulations on things with Python, right? This is a very easy thing to show, but anyways, this is one of the examples that we can do within Python, and this was actually taken from a Fabric notebook. Now, another thing that we're going to do today, actually, this is an example that we did today, that we're going to do today, is working with data. So we can create a list of columns, we can create a list of tuples with data, and then from that data and column names, we can create a data frame. And a data frame is basically a data set that lives in the memory of your PySpark session that we can then print to our outputs in the notebook. And you will see this nice little table for Alice, Bob, and Charlie with their respective ages. All right, so we can work with data and then manipulate that data. Now, usually you would read that data from a data set instead of creating it manually, but this is easy to use as an example, all right? And we can do more complicated stuff. We can start creating arrays and lists of arrays in order to basically run processes. And in the end, we're creating a directed acyclical graph here in order to parallelize a load of one of our ELT processes. With Python, you can do metadata-driven processing as well, in order to drive parameterization of your processes and so on. So there's loads of things that you can do to actually either do data engineering or to run the data engineering workloads that you've created. However, if you start writing code, whether it's Python or Java or SQL or whatever, you start writing repetitive code, usually. All right, at least as a data engineer. And I don't know exactly why we data engineers write repetitive coding, because when you're a software engineer, you write software, then the first thing that you learn is you never write repetitive code, right? You put things into modules and libraries and functions and so on, and you start calling those methods and libraries and functions and so on instead of rewriting them. And then we as data engineers say, no, we create stored procedures, and in every stored procedure we have the same merge statement to update or insert data into a table, or we have the same PySpark notebook with the same type of logic and so on. All right, so today we're going to see what that problem actually is. Well, there's a few different challenges that we run into. One is that we have duplicate code across different processes. All right, and duplicate code is quite a pain in the ass, to be fair. I run a company, we're about 10 people, data engineers, consultants, and when people start writing duplicated code across different processes or across projects or across clients, that is a big problem, because now when we change a thing over there, we might forget to change the thing at another process. All right. So we get discrepancies within our code. We have a lot of manual changes that we need to do, which leads to errors, because everywhere we write code, we write bugs, as you are all aware probably. And we have difficulty in scaling up, because every time we start scaling up to a new project, a new client, a new process, we need to update our code, and our code grows and grows and grows. So we need a lot of people to actually scale up, right? This is a problem because we don't have unlimited resources. So scaling up is important to do that efficiently. There's also this other thing. It's called the impact on productivity and on developers' happiness. And no, developers are not machines that you can feed coffee and pizza and then they write code for you. No, developers are actually people, and they need to be happy, because if they're not happy, they will go to another company where they can work and be happy. All right. And because we just discovered that there is not unlimited developers or engineers, we need to keep our developers happy. And we do not keep them happy by having them write the same piece of code 20 times in a day, forgetting it once, creating a bug, then spending a day to find that bug. And at the end of the day, they come home, their spouse asks them, what did you do? Yeah, I don't even know what I did, right? That's not what makes a developer happy. They want to be solving real life issues. They want to be helping customers to analyze data, to drive action out of um, data-driven work, and they do so by creating insights and dashboards and data engineering processes and so on, and not by duplicating code everywhere. So our productivity goes down, our developers' happiness goes down if we start writing repetitive code. That's not a good thing. We have a real world scenario here, because we might think, okay, this is not that big of a problem, but it starts compounding over time. All right. So let's say we have a dimension table in our data warehouse. Maybe it's the customer dimension or the product dimension. All right. We need to extend that. There needs to be two new columns into that dimension table. But that's not that big of a deal. We need to extract a few new tables from our ERP system. So we create a few new extract scripts. And then we start to create a few new scripts for our silver layer in the data lake, or for the persistent layer in our data warehouse. All right. So far, we've created maybe 4, 5, 6 new scripts just to extract data out of our ERP in order to drive those columns in our dimension. Then we start to add that data to the actual dimension table. So we will be adding a join statement to the query. We will be putting new fields into the mapping. We will also be putting those same fields in the insert update merge statement into the unknown member. Maybe they're slowly changing dimensions. Maybe there is other stuff. All right. So that's lots of work for just 1 or 2 new columns that we need to add to our existing table in a data warehouse. And now imagine that you're not running one table in a data warehouse, but you might be running 100 tables in a data warehouse, or you might be running 20 different clients with each having 100 tables in their data warehouse. And suddenly you're in a mess that you can simply not maintain and support anymore. So there's a cost to having repetitive code. All right. There's time spent on writing and debugging repetitive code, which gets more and more expensive. At least where I live, developers are getting quite expensive. There is an increased risk of inconsistencies and bugs across our code, which lowers the quality of things that we build for our clients. And then there's difficulty maintaining and extending the code base. All right. So it's not just the bugs that we write, it's also we want to maintain and update and start adding more value to the things that we have. And that will be more difficult over time as well. So please don't repeat yourself. Don't repeat yourself or dry. Okay, remember, you need to dry program, is a principle aimed at reducing repetition. It comes from the software development world. It's not something I came up with. It's something that is existing for a long time already. But we as data engineers can learn from that. And what it does, it enhances code maintainability and it facilitates scalability, which, as we just saw, are things that we want to tackle as data engineers, right? These are things that we want in our lives. So let's see how this principle of dry can actually help us. All right. The formal definition of the dry principle is that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. And now that is a very long and difficult sentence, but that has quite a few straightforward meanings. All right. So the word single in this definition means that everything should be configured in just one location or one script. Think about connection strings or file paths. All right. There should be a configuration file, or there should be maybe an API extraction method somewhere in a Python library that we can call that does the connection string part of the API call, instead of having every single table that I'm extracting defining the connection strings, right? There should be a single location where logic is stored, basically. Things should also be unambiguous. It should be clearly named and documented. For example, we should be using Python doc strings in order to document the functions that we write. And things should be authoritative. There should be a single source of truth for data models, for objects, etc., etc., etc. And that also, for example, that means that we have only one process and actually only one notebook to generate silver layer tables. Because if we create a silver layer table, we might move from files in our data lake to delta tables in our data lake. We might be normalizing the data types. We might be adding time travel information, and that can all be driven from metadata. So we don't need to create code for every new table that we add to the silver layer. No, we can have one single notebook that is metadata driven, and therefore is the authoritative notebook that creates silver layer tables. So going into the solution of the problem that we just saw, and on the how-to of implementing the don't repeat yourself principle within Microsoft Fabric Data Engineering, is using Python modules. All right. So for those that don't know what Python modules are basically packaged Python code that we can inject into a notebook, and then we can call the functions or the methods that are defined in that module. And we can use the code that is in that module without having to write that code in every process or every notebook that we're working with. All right, it's like having a library of code that we can work with. And there's loads and loads of open source libraries and modules, but you can also create your own. And later on in the demo, I'm going to show you how that works. So what we're going to do is we're going to find the most common functions and procedures that we have, and we're going to be sharing modules across projects. All right, because if I think of a very clever way to do something, then maybe it's not just good for my project that I'm working on that I can then reuse in different pieces of the project. No, maybe a colleague of mine wants to use that as well. All right. So we can think in a higher level of abstraction, where across teams or across clients or across projects, we can start reusing these modules. And then, of course, we have some benefits, which are actually the opposites of the risks that we just saw. Namely, it will save us time if we reuse code instead of writing the code again and again and again. It reduces errors because the less code I write, the less bugs I write. Usually that's the case. And if I find a bug, I can fix it once and it will be fixed everywhere. And it will simplify updates, because even we, as very good and gifted data engineers in our company, we are not always, I think, the best, right? So we find things that we can improve maybe after a month or after a couple of months. We think, this function could be a little bit more efficient, or this could be run quicker or using less compute resources. So we can update and we can improve our code. And if our code is only in one place, we can simply fix it in that one place and it will simplify updates for all of us. So why use custom modules to do this? It is about reusability. We can write it once and then use it everywhere. In our case, we use this across projects. So that means that our consulting company, we have a code base that we maintain on our tenants that we own the IP to. It's our intellectual property. And basically, we created a piece of software that is running inside Microsoft Fabric that we use for our clients. We created on our end, we built it on our end, and then we distribute the build to our client environments. And that is really the key to the use everywhere piece here. It also drives consistency by by standardizing processes across projects. What I mean with that is that you can have two very good data engineers, and they can come up with very different solutions to the same problem. All right. But then one of them goes on holiday or one of them leaves the company and his colleague needs to take over the project. And that might take quite a while before the new data engineer understands everything that happens, right? But by standardizing using these modules, everybody's using the same code, the same processes. So we have a lot of consistency in our projects as well. We can easily take over each other's work, and our clients are happy for it because they get a lot of consistency and they get a lot of quality out of it. And then there's the efficiency part of things. It really accelerates our development lifecycle. There's less time that we spend on reinventing the wheel because, I mean, if we need to solve a problem, it is probably already solved by someone else, right? It's probably already in our library or in our module. If it's not, we can create it, we can put it into the standardized model, but then it is less time spent by someone else reinventing the wheel after us. All right, so that makes sense, I guess. And also it enables collaboration because it makes teamwork a little bit easier, I think, if we're all working on the same code base. If we're onboarding new colleagues, they need to learn how we work, what we do, what type of quality we try to deliver. And if everybody's doing different things, then that's quite difficult. Also for teams that start working together, that might be quite difficult, but if we're all putting from the same processes, code, and so on, that might make it a little bit easier to collaborate. All right, so how do we go from a manual data engineer to a modular data engineer? So we start manually coding everything in repetitive scripts, all right? Then we might start to grab some of the things that we do in our notebooks and we start putting them into functions. But then we have functions locally in our notebook. We can reuse then that code in our notebooks. That is already good because we are reducing the number of repetition that we're writing. But we cannot easily use that same code across notebooks, across environments, across tenants, across clients. All right. So we then start building and importing custom modules using Python modules. And then we are really working on a very modular approach. So I created a few screenshots. This is the first one. This is very manual coding. And now the actual code that you're seeing here, this actual PySpark code that you're seeing here, it's, forgive me my French, it's a bit of bullshit. All right. What's happening here is not a real life scenario. It is just to showcase how repetitive code might look like. So what are we seeing here? We are seeing that we are creating three data frames by reading data from CSV files using the spark.read.csv method in the Spark library. Right, we're importing CSV files. We're setting the schema inference to true. We have headers, etc. All right. So there's some repetition in these three lines already. Then we're adding data. We're adding a date column actually to all of these data frames. So we created three data frames here in this piece, and then we extend those data frames with the date column. That's some repetition as well. So we might be fixing those issues. All right. So let's see what we can actually put in functions. The first thing is we can create a function that's called read CSV file, in which we ask for the file path, and then we simply return the data frame that is created by the spark.read.csv method. Right. Then in the middle layer, you see that we create a list of data sets with their respective file paths. And then at the bottom, we say for dataset in datasets. So for each instance of that list that we've just created, we open up a data frame. And instead of actually opening up the spark.read.csv on that file path, we call the method that we've just created at the top of the screen. All right, so we call read CSV file, and we put in the dataset file path parameter that we have there. So in here, the number of lines didn't shrink that much because we have only 3 data frames or 3 tables in here. But what if we had 300 or 3,000 tables in here, right? So we're already taking out some of the duplication that we have in the code here. Another example is this piece right here, where we are looking at the amount column, the date column, and so on that we are changing. So the second step that we had in the data frames, where we were adding a date column and maybe casting the amount column to a different data type, those can be generalized as well, because in every data frame we add a date column, then we can do it just once, or we can at least define it just once and then reuse that everywhere by creating a function called transform data frame, doing some stuff in that function, returning the data frame out of the function. And then for each data set in the list of data sets, we start calling that transform data frame method. All right. So we've now reduced the repetition in our code. However, this is still stuff that lives locally inside our PySpark notebook. So what if we have multiple notebooks? And I'll tell you, we will have multiple notebooks in a data lake in Microsoft Fabric. Or we will have multiple Microsoft Fabric environments if we are a consultancy and we have loads of clients, which I all hope we do. All right, so what do we do then? Then we start again repeating these functions. I mean, it's not as bad as it was before, but it's still not that good, right? So let's look at stage 3 using custom modules. Right now, we're not looking at a notebook anymore. We're now looking at a Python project in Visual Studio Code. And then again, this is just a screenshot out of a text editor. But bear with me, this is a Visual Studio Code project where we now create these functions. You see that in green, I put in Python docstring, so I actually documented my code. That's very important. Where we have the read CSV method, the transform data frame method, and they are now in their own project code base somewhere. All right. And then using our notebooks, we can start importing those methods into our notebooks, into our Spark session. And then we can simply call those pieces of code that are nowhere to be seen here in our notebook, but we can import them from the module that we've just created and published. And that makes it very, very easy to distribute code across many different notebooks, many different projects or clients. All right. So on one screen, that will look a little bit like this. Are there any questions so far on the theoretical side of things? Because we will be diving into the live demo right now. And I think it's
I don't see any
no
question
questions
here.
right now.
Thank
All
you.
right.
All
Oh,
good.
good.
All good.
I will run this cell so that my session will actually boot. That might take quite a while. So let's jump into the live demo. The session is booting up, so I have now some time to actually show you what we're going to do inside of this demo. There's actually a 5-step process that we're going through today. First of all, we're going to be creating a Python project using Visual Studio Code. Okay, now that sounds difficult. It is really not that difficult. I'm not a Python programmer. I learned Python as a data engineer. This is actually quite easy to do, all right? We're then going to package the code that we've written into a wheel file, a .whl file. All right, we create a wheel, and it's quite funny that they call this a wheel because it enables us to not reinvent the wheel. So that's something I found uh, quite interesting to see. But the good thing of the wheel file is that we can publish it to something called the Fabric environment. All right, I'm going to show you inside Microsoft Fabric how that works. We're going to then import that code into a notebook, and we're going to call and execute the methods that are in our wheel file from the notebook. All right. So if that's clear, then it's demo time. Let's head over to my web browser. The session started. It was only 5 seconds. So that's actually quite nice. And actually, I have a few examples in the screen right here. Let me know if the text might be a little bit too small. So let me zoom in a bit, if that helps. It's always a thing with sharing screens that might be too difficult, right, to read. All right, so in here, I've created the notebook version of our demo. All right, why the notebook version? I want to show that we can both create methods in a notebook and then start putting them into a Python module afterwards, right? So we can easily do a sandbox version basically inside our notebooks. We don't have to hop into Visual Studio Code right away. So this is a notebook that will demo the dry principle from within the notebook. We will be setting up two tables that are loaded into different incremental loads in order to demonstrate the process. First, we will define the Python methods that we are going to use in the demo. All right, so from delta.tables import star, forget about that for now. Let's look at the Python methods that we are, it's just one Python method that we have right here. Okay, so what do we have? I've created a method called upsert, and I will ask for a few different arguments in here. That is the Spark session object, a data frame, a table name, and a list of table keys. And then what I'm going to do is I'm going to test whether in my Spark session we already have a table called table/table name. And if we already have that table, we are going to perform an upsert. Now, for those of you that might not know what an upsert is an update or insert, depending on whether we already know the records that we're handling, based on a target table and a key column or a list of key columns. All right, so we're going to perform the upsert against the delta table, and we're going to use a merge condition that is doing a simple join on target key source key for every key in our table keys. And this is a very nice Pythonic way to define a merge join statement, basically, that in Python, in SQL might take you quite a few lines. Then after creating the merge condition, we are actually going to perform the merge by calling our delta table target and then executing the merge using our data frame as the source. We're going to call it source, with the merge condition that we've just created here on line 7, merge condition. And then calling the methods when matched update all, because if the key from our merge condition is the same, then obviously the record is already in our table. We need to update the record. If the record is not there, if the key is not matched, then we need to insert all. The record is not yet available, so we need to insert a new record into our delta table, and then we execute the statement, right? Now, if the table is not yet existing, if delta table is not true, we will simply copy the the data frame to delta. So what we will do is we will write our data frame into delta format, save as table with the table name variable that we've just created. Now, to prove to you that I did not prepare this beforehand, let's refresh the table section in our lakehouse in here, and indeed we can see we have no tables in here. So we ran this cell, we will run this cell so that the Spark session understands that this upsert method actually exists. And we're going to do the initial load of our users table by running this cell. Now you might know this piece of code from the one of the screenshots that I've just shown you in the slides, where we have columns and data. This is a list of column names, and this is a list of tuples containing data, where we will be creating a table called users, where the key consists of a list of one table, sorry, of one column in this case, the ID. So we have ID 1, 2, and 3 for the users, Alice, Bob, and Charlie, and their respective ages. 28, 35, 23. All right. We create a data frame with this data, and then we upsert that data frame by calling the upsert methods that we've just created. And then we start putting in the different arguments that this method expects with the data and the variables that we've created right here. Now in 20 seconds, this ran faster than I could talk. So now there should be a table in our table section called users. And thank the demo gods that this actually worked, because this might not always work if you do a live demo. We're all aware of the demo effect where everything works when you prepare and then you do the live demo and it doesn't work. Let's clear the outputs and let's check our newly created Delta table. And this time not using Python, but using Spark SQL. So let's create a data frame using select star from users and then displaying our data frame. So what's going on here? We actually, yeah, there we go. We actually created a table in our lakehouse with an ID, name, and age column for Alice, Bob, and Charlie. All right, so amazing. This was actually very nice. The table didn't exist, so our method created a new table by copying the data frame into the Delta table section. All right. So that was the initial load. Let's do a second load where we put in a changed name. Oh, sorry, not a changed name, a changed age for Alice. She changes from 28 to 29. And then we add a new record for John. His records will be newly added. Now let's run this piece of code. You will see that there is nothing that changed. The structure of the data is the same. The function that we have here is the same. And within 7 seconds, basically, we ran this piece of code. We can run a check here. And we see that indeed we now have 4 records in our table, with John being added at 61 and Alice now having an age of 29. All right, so we now proven that the code that we've written in our function actually works, and we have run our code twice without actually writing it twice. So that's already a little bit of dry programming. I did not repeat myself. I wrote the code once and then I started reusing this. And now you can imagine that if we start running, basically, I can just press run out. We'll run all the cells in our notebook. There we go. You can imagine that if we start doing a third load on the user table with Pietro and Jane, and then we start in the same run doing a new table for customers, even with a composite key and everything, blah, 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 where we have customer Microsoft and Apple and so on. It will be running, running, running. You can imagine that's what's going on, where we now have not one, but refresh 2 tables in our data lake with new records for our users, with the 2 initial records for our customers, where we do a additional load where we change some names, we added some new customers, and so on and so on and so on. And everything is just working as we expect. All right. We defined the code once, we ran it many times. It ran every time in the way we expected it. It loaded new data, it updated existing data, and we are quite happy with ourselves. Right. But now we need to use this in another process, or a colleague needs to use it with another client. So we start thinking, okay, how can we actually do that? We can do so by defining the code that we are creating multiple times. And that is actually that method that we have defined right here in our first cell. Right. So because I'm quite a lazy developer, I don't like typing and typing and typing. I will simply copy and paste and I will hop over to Visual Studio Code. Now let's zoom into Visual Studio Code here as well. I already created the Python project in here. So take a screenshot. Maybe I will publish I think I will publish the slides on my GitHub as well. But you need a few different files in your Python projects in Visual Studio Code in order to actually create the wheel file that we're going to do today. Version.txt, not that important. Setup.py, this is actually important. I'm not going to sign in, no. All right, requirements lists actually the dependencies that we have, so the other libraries that we're using. README is not that important for now. Notes. This was just my notes section basically for the demo. And then we have the ini.py. This one is actually quite important. Please include it. I will include the code sample in our in my GitHub as well. All right, and then we have a folder here called Absurd. That's the module, or actually this is a sub module that we're going to create, where we have put. You saw how quick I was with typing. I very quickly typed in here the same function that we had in the notebook. Now, for the people that are very familiar with creating methods in notebooks already, you might have seen me writing Spark session as one of the arguments here in my methods. Also here, I included this. And you might say, well, Bas, I don't need that. I can omit Spark session because I can simply call the object Spark inside my code and it will simply work. Yes, but it will only work within your notebook, because within your notebook you will have this object called Spark that contains the Spark session object that you can run your Spark workloads against. But your Python module that is running in your Fabric environment doesn't contain the Spark session object. So you need to give it the Spark session object that is created in your notebook. All right. And that's what we're doing here. We're creating a variable, or sorry, an argument called the Spark session. And we're using then that Spark session object from there on. And if you look closer in here, you'll see that we're actually passing on that Spark session object into this Spark session argument. All right. So if we just do the first option, we have the code in our notebooks. We don't really need this. We can omit this. If we know that we're going to put our code into a Python module, please put it in, because this will save you a lot of headaches debugging your code. All right. I will stop this session. I will go to my demo workspace and I will pick up my module thing in here and then start this session. That's an issue. Okay, then we go into Visual Studio again. Because the session needs to cool down before it can start up again. I should have done this in a high concurrency section, but that's another thing. So basically what we're doing now here is we have created our logic that we had in the notebook. We've created that in a .py file, in a Python file, all right? There's nothing that has changed, except for that we've imported the delta.table, something we did in the notebook as well. We now did it here in our absurd.py Python file, all right? So when we save this, we can close it down. We need to do a few things. We need to actually confirm that we're running Python 3 in our session. So in Visual Studio Code, go to your terminal and start writing Python 3 -- version. And if you hit enter and you get an answer with the Python version that you're running, you are actually running Python. If you're not running Python, you cannot create the wheel file. You cannot create this distribution mechanism, this build that we're going to need to input into our Microsoft Fabric environment. Okay, now let's see if this Fabric environment already allows us to start up a new session. It seems that it does. Okay, that's actually good. We're going to create a, by typing into the terminal Python 3 setup.py, we're going to use the configuration in our setup.py file. And we're going to create a wheel by doing this wheel, hitting enter. And now we are hands away from the keyboard. The laptop is doing things, and now we have created a wheel file. As you can see, there are some things that have changed here on the left side of my screen in my Object Explorer, right? I've created now 3 new folders actually. A build folder, a dist folder with a distribution, and an Absurd demo egg info folder. What's in here? It's not important for today. What's in here? It's not important for today. What's in here? That is important for today. I have actually now created a wheel file, a .whl file. And this file now contains the name of our project, Absurd demo. And then it creates a version number 1.0 that is in my version.txt. and it created that it is running using Python 3, actually. All right. This is the file actually that we need to put into Microsoft Fabric. Now this session is still starting up. Ah, there it is. That's actually quite good. Let's look at how we can actually, while this session is running, how we can actually create this environment that we need to run our code in. We go to new item. It's not in favorites. We go to all items and we start using the search bar for environment, and we create an environment. Doesn't matter, Bas, which environment we create. No, it's the same one. It's just under two different chapters. So we click new environment, we give the environment a name, and then we get this nice environment. I'm not going to do it right now because there is already an environment here called demo dry. So when I click it, you will get to see the same screen. And right here we have our environments. We can see in the environment what Fabric runtime we are running. We are running the Fabric runtime 1.3, which contains Spark 3.5 and Delta 3.2. We can downgrade to 1.2 if we would like. We don't, but we could. We see that there is lots and lots and lots of built-in libraries in Java, in Python, and in R. And if you're actually interested in, is my Python library A, B, and C included into Fabric, then you can look in here. You will find the Python libraries that are by default included into Microsoft Fabric. And I'm scrolling myself RSI in my right hand here. So yes, there's a lot of things included by default. We can also import from the Python package index public libraries. So if there's libraries that are not included by default by Microsoft, we can use the package index to include public libraries. But if we created something that is so cool that we want to sell it to our customers instead of making it open source in the package index, we can use our custom libraries. And right here, you see that I've already uploaded a file called the Upstart demo wheel. All right. How do we upload? By simply clicking upload here. And then we find the file. It will be uploaded. And then it will take about 10 or 15 minutes to actually synchronize. All right. So I did that already. I'm not going to do it right now because it will take way too many time. And I see that I am already over time for the demo. So let's quickly jump into this module piece of the demo. And let's remove the tables that we have right now. The session is ready, so that's also quite nice. There's been times that I gave this demo that it took 5 minutes to just start the session, and that's quite annoying. By now you know the drill. We import the upsert method as up, and we've basically the same piece of code everywhere, except for we're not calling the upsert method now because there is no upsert method here, but we call the up.upsert because from this module, from this upsert module, we can now include that code. And as you can see, there's no code here in the notebook, nothing. But when we hit run all, I'm not going to do them one by one. You know now what the cells are doing and what we are to expect. If we run this code right now, it will go through creating the tables, updating the table, the records in the tables, inserting new records, and so on. What actually having no code inside our local notebook. There we go. It should be showing us that the table is actually created. Yes, it created the table, and no, the create table statement is not in our notebook. All right. So this is actually doing the things that we expect it to do. Yoni is asking a question. Does the wheel file import libraries only installed within the environment? Yes. Basically, yes. So what that means is you will see up here in my screen that I am running this notebook inside the environment demo dry. All right. I can click change to workspace default, or I can click change environment or create a new environment. But right now I am running within the environment demo dry. Okay. What I can do is I can make my demo dry the workspace default, and then I do not need to put that into every new workspace. Oh, sorry, every new notebook. The notebook will automatically include the library that I included in that environment. So then every notebook can access that. There's also other ways to do it. You can do a pip install with a piece of code inside your notebook with a pip magic command, actually, where you can take your library from a GitHub repository or an Azure DevOps repository, perhaps. And then you can have the notebook fetch the library every time that you run it, which is actually something that we do quite a lot these days, so that we can use the same code across many different environments and Fabric environments as well. So Yanni, I hope that answers your question. If not, then let me know. All right, so here in the demo, we see that the code has run, the things that happened as expected did indeed happen. And yeah, basically there is no change in the functional outcome, only there is no code here in my notebook. The code is now centrally maintained in the environment through the Python module that we've created in Visual Studio. Now, or sorry, in Visual Studio Code, I should say. Now, it is of course not that convenient to be writing your code into Visual Studio Code, or maybe the writing code pieces, but then building the wheel file is not that convenient to do there. So in practice, what we do in our company is we will have some source control on this. We will put this code actually into a repository in Azure DevOps. In Azure DevOps, we have build pipelines running on the main branches, and that build pipeline is then generating a wheel file containing a version number, containing a build number, and that is exposed to a build output stream that is then being fetched by the Python pip install command in Fabric. And that gives us a little bit more control on how to actually distribute codes across many different platforms that we're trying to support. But this is the basics. If you're trying to start out somewhere, then this is something you can do today or tomorrow, actually, in order to start creating Python modules in your own projects. There's another question coming in from Tony. Can we achieve dry with using user data functions or user-defined functions? Yes, I think so, but only locally in the Fabric tenant or maybe even workspace that you're working in. I think it's workspace bound. I've not played with UDFs that much, so I'm not 100% sure, but I believe they are workspace bound. So yes, that will make your code a little bit more dry. But I mean, if you're going to do that, then why not start writing the code in Visual Studio Code, publish it as a wheel file, and then actually be dry across many workspaces, across many tenants, and across many clients. That would be a recommendation that I would have. All right, so what did we see? We saw the Python project and wheel file creation using Visual Studio Code. We saw the importing into Fabric. We called the methods that we just created, and that meant that we wrote our code once and used it many different times. We reduced the number of code, the technical depth, and the maintenance that we need to do on this code. And it will be easier to force development guidelines because I wrote my merge statement in a certain way. Maybe my colleague would have written it in a different way, not necessarily worse or better than my way, but different. So there is no handwriting for the single developer, which means that I can take over their work and they can take over my work quite easily. All right. Some of the key takeaways for today are that the dry principle will enhance efficiency in software development, and we can take this into data engineering as well. Custom Python modules are very powerful tools in the Microsoft Fabric ecosystem that we're not used to working with. Maybe I see some companies doing it, but I see lots of data engineers still writing low code data flows, or maybe they do some coding in notebooks, but they are not that dry aware. And what we can do by implementing an abstract framework is that it's easy to develop and maintain our Fabric solutions across many different clients. All right. Thank you all for being here. My name is Bas Land. I've been a BI consultant since 2013. I'm the co-founder of Kimura, which is a productized consulting company in the Netherlands, in Western Europe, where we sell a standardized framework for Microsoft Fabric. We do analytical products for several software partners, and we do some consulting on Fabric and Power BI as well. I'm married. We have a baby son. We have a dachshund called Chester, and I keep quite active. So I'm a purple belt in Brazilian Jiu-Jitsu. I do weightlifting and running on the side, so I keep quite busy. If you want to follow me, check out my LinkedIn or my technical blog at fabricguy.com, or email me directly at my email. And this is always a risk that I start getting bombarded with emails. But please be kind to me in the email. You can scan the QR codes to go to my blog or LinkedIn as well. If there's any questions, please let me know.
Boss, thank you very much. That was fantastic session. I'm super happy to see that you're doing
Nice.
jujitsu.
You do it as well?
The- no, I don't. I do
Oh, cool.
wrestling.
That's very cool.
I'm
Very cool.
wrestler. With gi or no
Usually
gi?
no gi. Yeah. Yeah.
No gi. Yeah, that's good.
Yeah,
Grappling
exactly. Yeah.
stuff.
There is some wrestling involved in that. Yeah.
Cool. Awesome. 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 So I've got a question for you from
Hmm.
my end. Uh, so that's great to have the custom modules and actually custom libraries for Python. And of course, from this section in the Visual Studio Code, VS Code, we can, just sync it to our source
Yes.
control. That's good. We can have those source control with the Git or
Yep.
Azure DevOps. Uh, how do you recommend for keep your updated version in your environment? Is it always a manual update? It is going to be really a mission, I think, when you have a new version of your function. Of course, the functions are not going to be created forever and and leave it there. And we need to just refactor that. We need to improve it. What is your method for just keep them in the latest version
Yeah.
always?
So the thing I showed you today was actually uploading a wheel file to a Fabric environment, and that is a manual thing that we have to do. So every time there's a new version of the wheel file, we have a new software release, we will have to go into Fabric, into the environment, and then say upload. We upload a new wheel file, publish it, wait for 10 or 12 minutes, and then we have the new code available to us. So if you're working inside of a company, in an end customer company, basically, that might be working for you guys, right? If you're working on consulting or in a software company, you're supporting many different Fabric tenants or environments, that might get a little bit busy, right? Then you might spend loads of times just updating all of your environments to the same version. So the latest developments, or at least it exists for a long time already, but the latest developments in our company right now, what at least the technical guys with us are doing, they are starting to use the pip magic command in notebooks, in order in every notebook to fetch a wheel file from a build output in Azure DevOps. And then we can use environment variables where we put the version number. So we say we're in version 2.1.4 or 2.1.5 or whatever, and it will fetch that version number from Azure DevOps using a PAT token, a personal access token. We can then take code or take the wheel file basically out of a DevOps repository, in order to be automatically updated to the latest versions.
Awesome. Awesome. Cool. Yeah, thank you. Because it is going to be very important to have always the latest versions. To have those files, those real files up to date. So, based on my understanding, we can have some sort of maybe environment or custom environment or notebook code to get the latest wheel file and upload it to the environment,
No, not to the
or
not to not to
you're
a
gonna
co-
keep. keep that in that notebook.
Yeah, so there's two things you could do. You can either upload the wheel file into the lakehouse, so into the storage of your data lake, and then start calling the code from there. That's actually something you can do. You can also run a Python pip install within the notebook, and then within every notebook, just fetch the latest version out of Git. Basically, that's the latter part is what we're now implement in our environments. Yeah.
Yeah, cool. And you have a comment from Arafat. This was really a wonderful session. I really appreciate Boss for your live demonstration on Microsoft Fabric as well as Python codes and VS Code. A huge congrats on both Mervil and Boss. Even I was a bit late. No worries if you were late. Of course, as you mentioned, you can rewatch it on YouTube channel. It is going to be available on our live section and in YouTube channel. Just share it with your friends and rewatch it. Thank you very much, everyone, for joining. I'm gonna share my screen quickly. Our session with Bas is done. So as I mentioned, you can just rewatch it on YouTube, and it is the YouTube channel address of at sign no the handler of Microsoft Fabric Cafe. You can just follow us on LinkedIn. Join us in the community group, start the discussions, ask the questions, and which is really important, asking the questions. When you ask the question, you're going to maybe share even more knowledge with the others. Maybe it's going to be the question for your other peers and other attendees. And so share your knowledge even in those discussions in the group. And just remember to rate today's session on our meetup group, which is very important for us, and join us on Reddit. So, Boss, thank you very much again for presenting at Microsoft Fabric Cafe. It is really appreciated, during the weekend, your personal time. Thank you. It is really appreciated. And yeah, if you want to add something, feel free to add it. If not, we can just wrap up the session and just wishing everyone a great
Thank you so
weekend.
much for having me. Have a
Have a
good
good
one. Ciao.
one.